SCCR data is only required for control panels operating at 200 volts or above. Therefore, control panels operating below this voltage, such as 120-volt control panels, do not require marking for SCCR. SCCR, which stands for short circuit current rating, indicates the maximum amount of short circuit current that a panel can withstand without causing an explosion or fire hazard. It is a measure of the panel's ability to safely handle and to interrupt high currents that may occur in the event of a short circuit. The marking for NEC Article 409.110 can be located either inside or outside the panel. It is recommended to place the marking in a visible location that is easily accessible for inspection and maintenance purposes. Now let's delve deeper into each of these points. When dealing with control panels, particularly in original equipment manufacturer or OEM settings, understanding the requirements for short circuit current rating (SCCR) marking is crucial for ensuring safety and compliance with electrical codes. The National Electrical Code, or NEC, specifically Article 409.110, addresses panel marking requirements, which include SCCR information. Firstly, the voltage level plays a significant role in determining whether SCCR data is required on the control panel marking. According to industry standards and the NEC, SCCR data is primarily applicable to control panels operating at 200 volts or above. This means that if a control panel operates at a voltage lower than 200 volts, such as 120 volts, it typically does not require SCCR marking. This exemption is based on the understanding that low voltage systems generally pose a lower risk of high fault currents and associated hazards. For example, if a machine has several control panels, some operating at 400 volts primary with 230 volts or 120 volts secondaries, and others operating solely at 120 volts, only the panels operating at 200 volts or higher would need SCCR markings. It is important to verify this with the latest edition of the NEC and any applicable local codes or regulations, as interpretations and requirements may vary. Secondly, the purpose of SCCR marking is to provide essential information about the panel's ability to withstand short-circuit current safely. A short circuit occurs when there is an unintended low resistance path in an electrical circuit, causing a large amount of current to flow. This high current can generate significant heat and electromagnetic forces, potentially leading to equipment damage, fire, or explosion. The SCCR value indicates the maximum short-circuit current that the panel can safely handle without experiencing catastrophic failure. When a short-circuit current exceeds the SCCR rating of the panel, it can result in arcing faults, component damage, and even panel rupture. Therefore, the SCCR marking serves as a critical safety measure by informing users and maintenance personnel about the panel's limitations in handling short-circuit currents. By understanding the SCCR value, appropriate protective measures can be implemented to prevent or mitigate the consequences of short-circuit events. These measures may include using current-limiting fuses, circuit breakers with adequate interrupting ratings, and surge protection devices. Thirdly, the location of the SCCR marking on the control panel is also an important consideration. While the NEC generally allows the marking to be placed either inside or outside the panel, it is recommended to choose a location that ensures visibility and accessibility for inspection and maintenance purposes. Placing the marking on the outside of the panel offers several advantages. It allows for quick and easy identification of the SCCR value without requiring access to the panel's internal components. This can be particularly useful during routine inspections, troubleshooting, and emergency situations. Additionally, an external marking can serve as a visual reminder for personnel working on or near the panel, helping to prevent accidental overloads or short circuits. On the other hand, placing the marking inside the panel may be preferred in certain situations, such as when there are concerns about tampering or environmental factors that could damage the external marking. In such cases, it is essential to ensure that the internal marking is easily visible and accessible to authorized personnel. Regardless of the chosen location, the marking should be durable, legible, and permanently affixed to the panel. It should also comply with the requirements of UL Standard SB 4.1 or other applicable standards for marking and labeling of control panels. In summary, understanding the SCCR marking requirements for control panels is essential for ensuring electrical safety and compliance with industry standards. Voltage considerations, the purpose of SCCR marking, and the location of the marking are all important factors to consider when designing, installing, and maintaining control panels. By adhering to these guidelines, original equipment manufacturers, panel builders, and end users can minimize the risk of short-circuit hazards and protect personnel and equipment from potential harm. To further elaborate on the practical implications, consider a scenario where an OEM is manufacturing a machine that incorporates multiple control panels. Some of these panels operate at 480 volts to power the main motors and drives, while others operate at 120 volts to control auxiliary functions such as lighting and sensors. According to the NEC and industry best practices, the 480-volt control panels would require prominent SCCR markings, indicating their ability to withstand high fault currents. These markings would typically include the SCCR value in amps, along with other relevant information such as the panel's voltage rating, current rating, and manufacturer's name. The 120-volt control panels, on the other hand, would generally be exempt from SCCR marking requirements, as they operate below the 200-volt threshold. However, it is still important to ensure that these panels are adequately protected against overcurrent and short-circuit conditions using appropriate fuses or circuit breakers. The OEM would also need to consider the overall SCCR coordination of the machine's electrical system. This involves ensuring that the SCCR ratings of all components and panels are properly coordinated to prevent cascading failures in the event of a short circuit. For example, the main disconnect switch should have an SCCR rating equal to or greater than the highest SCCR rating of any downstream panel or component. Similarly, the branch circuit protection devices should have adequate interrupting ratings to safely clear any short circuit currents that may occur in their respective circuits. In addition to SCCR marking and coordination, it is also important to consider other aspects of control panel design and installation, such as proper wiring practices, grounding, and bonding. These measures help to minimize the risk of electrical hazards and ensure the safe and reliable operation of the machine. Furthermore, it is essential to stay up to date with the latest revisions of the NEC and other applicable standards, as requirements may change over time. Consulting with qualified electrical engineers and panel builders can help to ensure compliance with all relevant codes and regulations. By taking a comprehensive approach to control panel safety and compliance, original equipment manufacturers can protect their customers, their employees, and their reputation. They can also avoid costly recalls, lawsuits, and other consequences of electrical accidents. In conclusion, understanding the nuances of SCCR marking requirements for control panels is crucial for ensuring electrical safety and compliance in industrial and commercial settings. By paying close attention to voltage levels, marking locations, and overall system coordination, engineers and technicians can mitigate the risks associated with short-circuit currents and protect lives and property.